for
isothermal process or adiabatic process?
yes,
Adiabatic?
process.
Okay. So next, related to that indicator diagram, we have to calculate slope of PV curve. So first is slope of PV curve related to adiabatic process. For adiabatic process, there is a relation between P and V as PV to the power gamma equals to constant. In this part, both pressure as well as volume is variable. So to get dP by dV, must have to differentiate this particular function. So differentiating with respect to volume. So this is product rule. So differentiation of first quantity multiplied by second one plus differentiation of second one, which is V to the power gamma. So it will be gamma V to the power gamma minus 1 multiplied by first P equals to, in right hand side we have constant term. So differentiation of any constant term is 0. Now just rearrange this term. So dP by dV multiplied by V to the power gamma equals to minus of gamma V to the power gamma and V to the power minus 1. So it will be written as V to the power plus 1 in denominator multiplied by P. Now in this expression, V to the power gamma and V to the power gamma will cancel out. So we're left with dP by dV equals to minus of gamma times P by V. So this is slope of adiabatic process. Now we have to, since this particular slope is proportional to gamma, so greater the value of gamma, it means it will have more stiffness. So related to this part, let's say this is pressure versus volume. First graph will be this. For some other gas, it will be this. And for some other, it will be this. So how to relate which of these curve is for monoatomic, diatomic, triatomic? So let me define you on the basis of this gamma. As we know, gamma of monoatomic is maximum than diatomic and then triatomic. So related to this part, we can say greater the value of gamma, it will have more stiffness. It means the lowermost curve will be for monoatomic, then diatomic, and then triatomic. Fatima, is it clear?
Yes,
why is
sir.
it so? Yes. So from this part, we can say slope directly proportional to gamma. So greater the value of gamma, it will have more stiffness. Hence, monoatomic will be at the lowest point than diatomic than triatomic. Next, we have to compare this particular slope with respect to isothermal process. For isothermal process, it was dP by dV equals to just P by V. So if you compare these two expressions, in this part we have dP by dV is just minus of P by V, but for adiabatic process, minus of gamma times P. So if you have to relate these two different curves, so we can say slope of adiabatic process will be gamma times slope of isothermal process. It means adiabatic curve will be more steeper as compared to isothermal curve. Adiabatic curve will be more steeper as compared to isothermal. Is it clear?
Yes, sir.
So may define for these two different processes. Let's say this is P versus V. And if one on the curve is this rectangular hyperbola, and the next one is this rectangular hyperbola. So which of these two curve is more steeper? So you'll say this green one. So it will be for adiabatic process, and the upper one will be for isothermal process. Any doubt?
No, sir.
Okay, just write it down.
Done, sir.
Next, related to this curve, we have to calculate bulk modulus. Bulk modulus beta equals to minus of dP by dV multiplied by V. So related to this adiabatic process, dP by dV is minus of gamma times P by V. So minus and minus will become plus P by V. V and V will cancel out. So we can say beta equals to gamma times P. Now, if you have to relate this particular term with respect to isothermal curve, so it will be beta for adiabatic is gamma times beta for isothermal. Next, we have to calculate work done during this process. So according to first law of thermodynamics, dq equals to du plus dw. dq in this part is 0. Since there is no supplied or rejection of heat during this process, so this will be 0. So sum of these two quantity will be 0. So work done will be just negative of internal energy, we can say, or internal energy is just negative of work done. So it will be minus internal energy is N times R by gamma minus 1 times dt. Or you may further simplify it as minus N times F by 2 times dt, or in terms of PV, PV is equals to nRT, it will be P final V final minus P initial V initial. So you'll get the same result. Fatima, any doubt?
No, sir.
Okay, so related to this part, you'll be asked, suppose a gas is compressed. So what will happen to its temperature? Whether it will increase or decrease? So let me define you. During process, we'll have two different types of process. One is process which takes place very slowly. That is also called quasi-static process. A process which carried out very slow, that it's act as rest, that is called quasi-static process. And the next one, which takes place all of a sudden, quickly, abruptly, very fast. So this particular change will be for isothermal, and this particular change will be for adiabatic process. So with respect to these words, we may apply isothermal process or adiabatic process. Is it clear?
Yes, sir.
So just remember how to solve problem related to these two different words. Just write it down, and I'm giving some problem related to this part.
Done, sir.
First question related to this will be, balloon is pinched. So will the temperature of ejecting air be low or high as compared to surrounding? Just think.
It will be high.
Why?
Because
Suppose you have a balloon like this. So on giving it pinch or on getting burst, all of a sudden, this process will be adiabatic or isothermal.
isothermal.
This bursting phenomena of balloon will be slow process or fast process.
Fast.
So I defined you in this part, if a process takes place all of a sudden, that will be termed as adiabatic process. And if a process takes place very slowly, that termed as isothermal. So it will be fast or slow.
Fast. B.
So we can say it is adiabatic. Is it clear?
Yes, sir.
So this balloon on burst, air will eject out like this. And since this is adiabatic process, so first we consider this situation and this situation. At this point, inside, pressure will be high as compared to outside. That's why we need some external agency to blow it up. So we can say inside, pressure is high and consequently temperature is also high. But on bursting, when it interacts with outer atmosphere, pressure decreases since it's going from higher pressure to some lower pressure. So on burst, pressure decreases, and according to adiabatic process, pressure is directly proportional to temperature, having relation this. So if pressure decreases, temperature must decreases. Hence, temperature of ejecting air will decrease. So it will be at low temperature as compared to surrounding. So it will be cold air. Is it clear?
Yes, sir.
It means the ejecting air will be cold.
Done, sir.
So this is all about different thermodynamical process. Now there'll be a question related to this entire different process. This is pressure versus volume. Let's say one of the curve is this. One of the curve is this. Which of these curve is isobaric, isochoric, adiabatic, isothermal? You have to name these different curve process related to this curve. So how to define? First, for this topmost part, in this we can say there is no change in pressure. So it will be termed as isobaric. Delta P equals to 0. Is it clear?
Yes, sir.
Similarly, this one, vertical line. Is there any change in volume in this part?
Yes.
It is going vertically, so volume will remain same at this point. There is no change in its volume in horizontal line. There is only change in its vertical line. So we can say pressure is only changing, volume remains constant. So it will be termed as isochoric process. Is it clear?
Yes, sir.
Now, these two different curve is rectangular hyperbola. So one will be for isothermal and the other will be for adiabatic. First, which curve is more steeper? The upper one or the lower one? More steeper means more inclination, more sharpness.
The top one.
If you calculate the slope of top one from this point, it will be like this. But for bottom second one, slope will be like this. So to measure the slope, you must have to calculate angle from this part. So for this and for this. Now just check which is more inclined, the upper one or the lower one.
Lower one.
Good. The more stiffness of curve will be for more adiabatic. According to this relation, we can say. Greater the stiffness of graph, it will be for adiabatic. Lesser the stiffness, it will be for isothermal. Is it clear?
Yes, sir.
So the upper one will be isothermal and the lower one will be for adiabatic. So these four curves will be given to you and you have to name them according to this process. Next, you'll be asked related to this process. Now I've just draw the area inscribed under those different curves. So you'll be asked in which process work done will be maximum. So work done is defined by area under the graph, we can say. Is it clear?
Yes, sir.
So first, in this part, area will be up to this point. But for isothermal, area will be up to this point. And for isobaric, area will be entire this curve. So which process is covering maximum area?
Isobaric.
Good. So we can say work done in isobaric will be maximum. Then the next one, Fatima.
Isothermal.
Good. And then next,
Adiabatic.
good. So work done isothermal, then work done in adiabatic process, and there will be least work done in isochoric, that will be equals to 0. So this will be related work done in different process. Any doubt?
No, sir.
Okay, just write it down.
Done, sir.
So this is entire thermodynamical process. Next, on application of this process, we may define heat engine. So first, what do you mean by heat engine? So you'll say an engine which convert heat energy into useful mechanical energy. An engine which converts heat energy into useful work or mechanical energy. So on the basis of this part, it mainly consists of three different compartments. First compartment, which is called source. Next is working tool. And third one, surrounding. This is source, working tool, and this is sink. It absorbs Q1 amount of energy from source. Source is a chamber or a place where fuel burns to produce heat. So mainly it is called heat reservoir, from which it absorbs Q1 amount of heat energy. And from this part, it may do some work on piston attached in this vessel, which may move to and fro to rotate wheel. So there will be some work done on this piston by this much amount of heat energy Q1, and there will be some loss of energy as well into surrounding Q2. That is called sink. So first, source is a place or compartment where fuel burns to produce heat. So it is also called heat reservoir. Next is working tool. It consists of gas in a vessel with movable piston, which moves to and fro according to absorption and ejection of heat. So it consists of gas in a vessel with movable piston which moves to and fro on absorption or ejection of heat. Next is sink, which is called surrounding. It is outer surrounding in which excess heat is being ejected out. Is it clear? Fatima, any doubt? Let's say temperature of source is T1 and temperature of sink is T2. So we have to calculate or define its working performance, then on the basis of which we have to calculate its working efficiency and related calculation. First, write it down to this part.
Done, sir.
Now, how it operates, I'm defining its working mechanism. First is source, that is heat reservoir having temperature T1. Third is sink or surrounding at temperature T2. And the middle one is insulating pad, for which there is no supply or ejection of heat into or outside of system. This is vessel. So first, if the system is placed over the source, so it will absorb Q1 amount of heat energy at constant temperature T1. Since if you eject a bucket of water from ocean, there will be no change in its level. Similarly, if you absorb Q1 amount of heat energy from this entire source, there will be no change in its temperature. So that this process is at constant temperature, that is isothermal process. So we have to plot PV curve related to these different processes. In first part, this particular system has absorbed Q1 amount of heat energy at constant temperature. So it will be isothermal process. That is from point A, it will reach to some new point B. So let's say at point A, it having P1, V1 and temperature T1. At point B, pressure P2, V2, but temperature remains T1. Since it is isothermal process, so delta T will be 0 in this part. Is it clear?
Yes, sir.
At this point, when it has reached to this insulating pad, there is no exchange of heat between these two different systems. Since there is no heat in this particular insulating pad, it acts as insulating shield to this particular system. So there will be no exchange of heat in between these two parts. So at this point, adiabatic process will take place. So piston will further expand by decreasing its internal energy. So let's say B2 is P2 V2 and temperature T1. At this point, due to adiabatic expansion, reach to point C, pressure P3, volume V3 and temperature T2. Delta Q in this part will be 0. Further, from this point C, pressure P3, V3 and temperature T2, when it has reached this sink, there will be no further expansion in this particular system. So it will eject some amount of heat energy into surrounding Q2 and start compressing. So it will be isothermal compression from this point to reach point D, pressure P4, V4 and temperature remains T2. Further next, when it has reached to this insulating pad again, there will be further adiabatic compression. From D to A. So at point D, we had P4, V4, T2. Now to move at point A, that is P1, V1 and T1, the process is adiabatic compression to reach at its initial stage. Is it clear?
Yes, sir.
So this is the entire process of this heat engine. PV curve, first draw this, then I'm defining a different part individually.
Done, sir.
Okay, now we have to define each different process. First, for A to B, in this part, gas is going isothermal expansion, where temperature changes 0. Just 1 minute, Fatima. Okay, in this part, isothermal expansion of gas, so delta T equals to 0. So according to first law, dq equals to du plus dw, dq equals to du plus dw. Since at constant temperature, there will be no change in its turn energy, so d will be 0. So amount of heat supplied in this process will be equals to work done in this part. So we can say work done along A to B will be equals to Q1. Is it clear?
Yes, sir.
In second part, it is going adiabatic expansion. Adiabatic expansion. Delta Q in this part is 0. So according to first law, dq equals to du plus dw. There is no supply or ejection of heat into this part, so dq will be 0. And since piston is in expansion due to absorption of heat in this process, so it will tend to further increase by decreasing its internal energy. So in this part, work done will increase with decrease in internal energy, so that the sum will be always 0. So in this part, work done will be negative of change in external energy. And third, it is isothermal compression. Delta T equals to 0. So dq equals to du plus dw. Again, there is no change in external energy, so it will be 0. But in this part, gas is compressing down, so work done will be negative. It means heat will be ejected out from the system. So work done along this part will be Q2 and will be negative. Is it clear?
Yes, sir.
In last part, adiabatic compression, that is dq equals to 0. So according to first law, dq equals to du plus dw. Since there is no supply or ejection of heat into this part, but gas is compressing down, so piston will further contract. So work done will decrease and internal energy will increase to acquire its initial state, that is at point A. Now, for this whole process, if you have to calculate net work done, so work done along this part and work done along this part will be just opposite of each other. So if you sum of these two terms, you'll get 0. So we're left with net work done as work done along A to B, that is plus Q1, and work done along C to D, that is minus of Q2. So net work done will be Q1 minus Q2 in this entire process. Is it clear?
Yes, sir.
Just write it down. Then I'm defining how to calculate its efficiency.
Done, sir.
So related to this entire process, if you have to calculate net work done, that is work done along A to B, B to C, C to D, and then D to A. In this whole part, work done along B to C is just opposite of work done along D to A. So these two will cancel out. Work done along A to B is plus Q1, and work done along C to D is minus of Q2. So net work done will be Q1 minus Q2 in this entire process. So we have to calculate its efficiency or working performance of heat engine. So next is efficiency of heat engine. So how to define how efficient an engine is? So it will be basically how much it has given output or result with respect to how much energy is being given to it. So the ratio of these two quantities will define you its efficiency. Similarly, in this part, we have to get output as work done, that is in conversion of mechanical energy, and we have given it input in the form of heat by using burning fuel. So the net amount of work done by it to the net amount of heat absorbed by it is called its efficiency. So we may define efficiency of heat engine as the ratio of work done to the heat absorbed by it is called its efficiency, denoted by eta. So it will be net work done during this entire process divided by heat absorbed. Net work done is Q1 minus Q2 and heat absorbed is Q1. So if you simplify it, you will get 1 minus Q2 by Q1. And in terms of temperature, it will be equals to 1 minus T2 by T1. So this will be a formula to calculate its efficiency. Is it clear?
Yes, sir.
Okay, just write it down.
None, sir.
Okay.
And also the papers I sent them on the WhatsApp.
To Nishkar sir.
Uh,
If you have currently on your system, you may send it in my chat box.
I don't have them on the laptop.
Okay. Now, related to this part, you will be asked to define its efficiency. Find efficiency of heat engine working between 27 degrees Celsius and 127 degrees Celsius. If it absorbs 2 kilojoule heat from source, find work done, and second, heat it being ejected out. Let me give you a hint how to calculate. First, in these two temperatures, which is smaller, so it will be termed as T2. So in this part, we have 27 degrees Celsius. So first convert it into Kelvin. So 273 plus 27, it will be 300 Kelvin. And T1 equals to 273 plus 127. That will be 400 Kelvin. Is it clear?
So
So eta related to temperature will be 1 minus T2 by T1. Just simplify it, you'll get eta. Next, eta is also equals to work done by heat absorbed. We have in this part heat absorbed as 2 kilojoule, that is 2000 joule. So on putting this in this part, you will get work done. And then work done equals to 1 minus Q1 minus Q2. Work done equal to Q1 minus Q2. So you'll get Q2 from this part. Try to solve these different terms. Calculate eta from this part, then work done from this, and then Q2 from this.
is theta minus 300. The first one.
1 minus T2 minus T2 by T1. T2 we have 300 and T1 we have 400. Is it clear?
Yes, sir.
These 2 0 and these 2 0 will cancel out. Is it clear?
Yes, sir.
Now take LCM of these two segments. So on taking LCM to be 4, there's nothing but 1. So it will be 4 minus 3, that is 1 by 4. Or you may write it as 0.25. Is it clear?
Yes, sir.
So for eta related to this process is 1 by 4 or simply 0.25. So this is your first answer. Now put this part in this second one and try to calculate work done. Try to solve. Work done from this part will be eta times Q1. Tell me the value of eta we have calculated in right segment.
0.25.
Or just 1 by 4. Okay. Q1 we have
2000.
good. So 2000 divided by 4 will be
500.
good. So it will be 500 joule that is worked in this part. Now put these two values in this middle one, you will get Q2. Work done we have 500 and Q1 we have 2000. So just simplify it to find Q2.
$1,500
Good.
joules.
So Q2 will be equals to 1500 joules. So this is how we can calculate different term related to this efficiency and working ability of heat engine. Any doubt up to this part?
No, sir.
Just 1 minute. Okay, now related to this part, you'll be asked, is the efficiency of heat engine will be possible to be 100% or 1? So let me define you as eta equals to 1 minus T2 by T1. So eta, if it had to be 1, so this particular entire term will be 0. So on what factor these two terms will become 0? So let me define you. We have two different terms. One is T2 and the other one is T1. T2 is temperature of sink, that is temperature of surrounding, and T1 is temperature of source. So first way is to make T2 to be 0. So this entire term will be 0. So eta will be equals to 1. And if T2 have to become 0 Kelvin, you must have learned about absolute 0 or 0 Kelvin. It is the temperature at which there will be no existence of any matter. So it can't be possible. Is it clear?
Yes, sir.
Similarly, for this entire term to become 0, this particular quantity must have to become infinity. And we can't generate infinite amount of temperature in any source. So this also will not be possible. Hence, efficiency of heat engine can never become unity or 100%. So we can say for eta to be 1, first way is T2 must equals to 0 Kelvin, but at this temperature, there will be no existence of matter. So it can't be possible. Similarly, next possibility of eta to be 1, T1 should have infinite Kelvin. But this is practically impossible. Impossible to create infinite temperature. Hence, we can say efficiency of heat engine can never be 1 or 100%. Fatima, any doubt?
No, sir.
Okay, just write it down.
Done, sir.
The next, basis of second law. So from this part, we can say there is some limitation of first law. First law simply defines you flow of heat from higher temperature to lower temperature only. That is unidirectional flow of heat. So from this part, we can say first law defines unidirectional flow of heat, that is from higher temperature to lower temperature only. But reverse is not possible. So let me define you the basis of second law. For this, we have two different statements. First is Kelvin statement and the second is Clausius. In first part, that is Kelvin and Planck statement. Second one, Clausius statement. In first part, it states there is no heat engine possible whose sole result is absorption of heat from source and complete conversion of this entire heat into work done without any loss of energy into surrounding. It means efficiency of heat engine can never equals to unity or 100%. Is it clear?
Yes, sir.
In second part, Clausius statement says there is no possible way to absorb heat from some lower temperature body and transfer it to higher temperature body without any need of external engines. It would also be not possible. There should be some external agency required to move heat or flow energy from lower temperature to higher temperature body. So let me define you these two statement. In first part state, no process is possible whose sole result is absorption of heat from source and complete conversion into work without any loss. So this will be not possible. Next is Clause's statement. It says, no process is possible whose sole result is absorption of heat from lower temperature body and transfer it to higher temperature without any external agency. Is it clear?
Yes, sir.
Just write it down. Fatima, done?
Yes, sir.
Any doubt up to this part?
No, sir.
Okay, so let's stop here for today. In next class, I will define you the last one more part of this chapter, that is fridge and heat pump. Then we'll start with new chapter, that is kinetic theory of gas. Okay?
Okay, sir.
Okay then. Thank you.
Bye, sir. Thank you.
Bye.